Hello and welcome to this video on connected particles. So we're going to start this question, as we should almost any question in M1, by drawing it. Okay, so we've got two particles A and B with masses 4 kilograms and 7 kilograms. Okay, so we're going to draw the ground first. Okay, here we are. Then it's on this slope. This angle is 30. Okay, so then we've got a pulley here. Right, so then this is particle B, this is particle A. Okay, there shouldn't be any sort of gap here. Yeah, A is here. Right, and now we want to draw on the forces. So both their weights. So this is going to be, this has mass 4 kilograms, so this is going to be 4g. This has mass 7 kilograms, so this is going to be 7g, going down. Okay, then tension, and reaction. Okay, what else can we draw? Okay, we know, we want to find out what the acceleration is. Okay, so we want to think about which way it's accelerating. What's going to happen in this situation? Okay, so B is heavier, so what's going to happen is this particle is going to accelerate this way, and particle A is going to accelerate up the plane. Okay, now what we want to do is resolve this 4g, so it's in the same as the line of motion, i.e. the line of acceleration. So it's accelerating parallel to the plane, so we want to resolve this 4g parallel and perpendicular to the plane. Okay, so is the 30 degrees here or here? Well, it can't be here, because this is a right angle, therefore it must be here, so this is 30 degrees. Okay, so then this component will be 4g, because that's what we're resolving, 4g, cos, because it's adjacent to this 30. Okay, and then this component will be 4g sine 30. Okay, now we've got everything we want, we can write some equations, right? So we're going to use F equals ma. Okay, so let's first do it for particle A. So we're resolving up the plane, the line of acceleration. Okay, so the resultant force, F, is equal to everything going this way, i.e. the way it's accelerating, minus everything going this way, i.e. the way it's not, like opposite to the way it's accelerating. Okay, so this is t minus 4g sine 30, and this is equal to mass times acceleration. Mass of A is 4, so this is equal to 4a. Okay, now let's do the same thing for particle B. Okay, this one's accelerating down, resolving down. Okay, the resultant force F is everything going the way it's accelerating, i.e. everything going down, which is 7g, minus everything going in the opposite direction, up, so minus t. And that's equaled, again, using Newton's second law, equal to ma, and this one has a mass of 7, so equals 7a. Okay, now we want to add these together, so solve them as simultaneous equations. The t's cancel, we get 7g minus 4g sine theta equals 4a plus 7a, which is 11a. Okay, so we've got 7g minus, we know that sine 30 is a half, so we've got minus 4g times a half, which is minus 2g, and that's equal to 11a. So we've got 5g equals 11a, therefore a equals 5g over 11. Units, ms to the minus 2. Okay, now what else did it ask for in the question? Tension. Okay, so we can just substitute back into either of these formulae. Let's substitute back into this one because it's easier. So t minus 2g equals 4a. So let's substitute in what we know, and let's add 2g to both sides. So we've got t equals 2g plus 4 times 5g over 11, and then put that in your calculator, whatever you get. I guess in this case it's like 37.4, and the units are newtons. Okay, I'm just going to walk you through the next bit. So for part part II. Let me circle it. Okay, good. Right, so what speed is B travelling when it hits the ground? Okay, so this distance that B travels is 1 meter. Okay, so we're using SUVAT. S equals 1. U equals 0 because it started from rest. So we're thinking about how far, like, what's changed since it was released from rest. Okay, A, we just found that is 4.45 ms minus 2. Okay, and we're looking for V. Okay, so we use V squared equals U squared plus 2AS. And then we use that to find V. Okay, and then so that's part II, part 2, and for part 3, so how far can A travel before it starts to descend again? So this is exactly the same as one of those questions where it says you throw a ball up in the air and how long till it reached its highest point, okay? When A starts to descend again, that will mean that instantaneously the speed is 0. So for our SUVAT, we've got V equals 0. U is whatever we found here as V. Okay, so basically the acceleration changes when B hits the ground. Okay, when B hits the ground, this tension goes away because that string is no longer taut. Okay, so there's no tension. Instead, we have the only force we have is going that way and is 4g sine 30. Okay, so now our new acceleration will be minus 4g sine 30 divided by 4. That's using F equals ma because this bit I'm circling is F, and that will be equal to 4a, and then we just divide by 4. Okay, so this is our acceleration. Our u is whatever we found here, and we are looking for how far it goes. S equals question mark.